I would say today's objective is not to do your actual road design for you, but to rather show you how your road can be designed. So I'll take you to a stage where you're able to look at your road from this perspective. I'm going to exit this render view. And what I've done is I've put a workflow together for us. And as we go through today's demonstration, we can refer back to this workflow. First of all, we'd only open the DWG drawing and we'll do a Google Earth check to see that it is coordinate correctly. So I'm going to do that. I'm going to go to File, Open up the raw data that you gave to us. When you open up the drawing, you have the option of specifying your drawing settings. You could, for example, go and change your paper size. Depending on how the DWG was saved, you would then go and select the appropriate option. I've opened it already, and with your drawing we negate the coordinates. And what that does is it swaps around the symbols of your coordinates. So instead of negative, it would be positive and vice versa. Next step would be to create a project. We've got the drawing. We want to associate a project with the drawing. So we go to File, Project Settings. Maybe a good idea to go to your survey mode first. File, Project Settings, and then go and select the terrain option. And then call this Demo 2. And then I will save it just in case we need to use it at a later stage. Click on Open. Confirmation that this file doesn't exist. Do you want to create it? Yes. Then looking at the name of your drawing, we've got Limpopo 29. So in that case, I go and change this to 29 degrees east. If you're not quite sure, you can always use this presets button. You can go and specify where in the world your project is situated. Having set that up, click on OK. Now I want to export this into Google Earth as a check to see that it's been set up correctly. I do so by going to File, Export, Google Earth, specify what you want to export. I'm just doing the CAD for now. Click on OK. Give it a file name. Civil Designer will then create a KML file that is readable in Google Earth. It will automatically go and open up Google Earth in the correct georeference position. This Google Earth version that we have in front of us is available for free off the internet for download. So it's not something extra you need to budget for. You can see that our drawing is positioned correctly, and if you were to look at the boundary lines, they are aligned with the backdrop image. I'm happy with that. I'm confident that I've got the correct coordinates, so I'm going to go and close the Google Earth. Then zooming in, let's first of all go and turn off all our CAD layers and then activate the contour layers. Zooming in, you can see what your contours look like, and if I were to go and select these and right click and select properties, they are lightweight polylines and they do have elevations associated with them. Ideally you want a survey, but if you don't have a survey, this is good enough. Just be careful. In some places you might have very large gaps, so your design might not be as accurate using these contour lines instead of a full-on survey. I can either go and put in a big selection window around it, or I could go and press Ctrl A on my keyboard and select everything. Then going to the survey mode, you go to File, Import, just looking at the different options available to you. Normally when you have a survey, you can import it via ASCII file. You also have the option of Land XML, LiDAR, but in this case we'd only convert the drawing entities, and then we go and click on Selected Polylines. Very important in this example is to pick up the elevations from these polylines. You've got 255 different surfaces to choose from within a single Civil Designer project. We'll use surface number 1. I'll generate them as break lines, and the method is for contours. Click on OK. It then goes and converts these polylines into surveyed points. I'm going to go back to the CAD layers. I'm going to turn off those two CAD layers, zoom in, and you can see we've got points. If I were to go and turn on the elevations, all these points have elevations. Turning off the elevations, turning on the line model, you can see what it looks like. Just to bring back that workflow chart, we've opened up the DWG and we've done a Google Earth check, so I'm going to scratch that out. We've done DTM creation from polylines, and we haven't triangulated yet. I'm still getting there, but I'm going to go and scratch that out. We haven't done any error checking yet. Looking at removing duplicates. Now, it may be that your or any drawing has errors on it, and you don't want to have the errors on your DTM because down the line you then have problems with your design. So it's a good idea to go and check for any duplicated points. In the survey mode, we go to editing and we select remove duplicates. You can say use height in comparison. So what that means is if you've got duplicated points with X, Y, and Z coordinates, it will then go and delete a random point. This function would probably take 5 minutes, so I'm not going to do it at the moment. I've already done it in this project, and eventually we then revert back to that project. But for your information, you would now go and click on OK. Once you've gone and checked for duplicates, now we're going to go and do the triangulate functionality. Before you triangulate, you probably want to know more or less the distance between your surveyed points. You could press Q on the keyboard, click on a start point and an end point, and that would give you a good idea as to the distance between your surveyed points. Depending on where you've clicked, you'll get a certain distance. I'm going to use 45 meters as a benchmark. So looking at our project, we go to the terrain mode, we go to model on top, and we select triangulate in memory. Specify that maximum line length of 45 meters, click on OK, and it goes and joins all our surveyed points. So if I were to zoom in, you'll see it's gone and closed the gaps within our DTM. Pressing ZA on my keyboard for zoom all, we can go and check for any errors. So I go to model, validate model. We're validating surface number 1, click on OK. Not only does Civil Designer tell you that you've got an error, but if I click on OK, it actually points out where the error is. I'm going to turn off the elevations. If you don't validate successfully, it may be a good idea to go to Model and remove invalid lines. Specify which surface you're working with and click on OK. Again, this function takes a bit of time, so I'm not going to do it now. In your case, you click on OK. Going back to our checklist or workflow. We've now done the DTM error checking. We've removed duplicates, we've done the validation, and we've removed the invalid lines. Next up, CAD prep work. We then identify the problematic areas and speak of the geometry functionality. If I were to go and turn on your centerline CAD layer, let's zoom into the end of the road here. Now you can't quite see what your line looks like. If I go and click on it, you get a better idea of what it looks like. And from this you can see you've got numerous lengths. Now in an ideal situation, you want this entire polyline to be one line. Let's change the line type so we can see it more clearly. I'm going to press zoom all. I can go to my CAD mode and I can go to edit, select by filter, quick, specified entities. We're looking at polylines matching a certain layer of centerline. Click on OK. Right, so the entire centerline is now selected. I can then go to properties and change the line style. Let's select continuous just so that you can see it more clearly. zooming in again. There we go. So there's a better idea, and then turn off the triangulation lines. If we go back to the end of the road, you've got to be careful because our road actually falls off the DTM. So you want to ensure that it is on the DTM. If we look over here somewhere, there's actually a gap. I think it was over here. Before I switch off the triangulation lines, at this stage you would want to add additional brake lines where my cursor is positioned. This is done by going to Terrain Mode, Model, Brake Lines, Add. There's a gap between the lines, which of course you don't want. If we go to the beginning of the road, you don't require this line as your main road. You would right click and go and select Remove Vertex, and in that case you have the option of clicking on these handles and then just using the relevant information. As well, in some places there's quite a bit of zigzag happening with your road, which ideally you don't want. So what I've done, I think over here somewhere there's a bit of zigzag. Something like that. You don't want your road to have so many kinks in it. So what I've done is I've gone and created my own polyline for the entire road because we don't utilize that for the design in this case. Zooming into the beginning of the road, there's different tools that you can use. I've gone and used the geometry functionality. As an example, I've gone to Geometry, Lines, selected through 3 points, and then gone and selected, I'll go and click on this icon here which jumps to the closest entity, and then I've gone and clicked on 3 points on this circle or this curve. One there. Let's do the same over here just so that you get an idea of what it all looks like. And then I went to Geometry again, Lines, Tangent to 2 circles, clicked on the 2 circles, and then specified the tangent position. That is how I went and put in a new polyline. I went to Draw and I selected Polyline, Lightweight Polyline. Looking at the workflow chart, we've now gone and did the CAD prep work. Go and scratch that out. Now we're going to create roads and we're going to look at the procedure involved with that. So I'm going to revert back to the original project. I'm then go to the roads mode. I don't have to export to any other software program. If I were to go to File and select Project or Option Settings, you can design up to 2,500 roads in a single Civil Designer project. You also have the option to use the Interactive Road Expert, which I normally do in my demos. And in that case, the road design process is automated, so Civil Designer guides me through the design. But in our case, I'm trying to go into more detail as far as the road design is concerned. So I'm going to do the design almost manually, and I'm going to turn off use this Interactive Road Expert for now. I'm then go to the display settings and I'm going to turn off the road that we already have. That's the one I showed you in 3D. And then I'm also going to go and turn off our surfaces. If I go to my CAD layers, I've gone in, as mentioned before, created a new polyline that we will utilize for our design. I go to File, select Road File. I'll use this road 2. We'll look at different design alternatives, and then when we do the actual design, I'll use road 3. So with road 2 selected, you can go and specify the different generation options. I would suggest that you use strings. String automates the junction design. So looking at many roundabouts, cul-de-sac, intersections. You specify a template, which we'll go into more detail at a later stage. And we're working with surface number 1. Within a single road, you've got 128 different cross-sectional layers that you can use, and then it's very easy to go and customize how you want this to be displayed, and then save it and load it at a later stage. Having done that, let's look at the first design alternative. What I did beforehand is I went and put in the geometry lines, which I'm now only going to turn on, and I'm going to zoom in. Now it looks like there's a lot of detail. I see I've got my road markings on, so I'm only going to turn that off. It looks like a lot of detail, but remember we're dealing with a almost 27 kilometer length road here, and I've gone and customized it according to my likings. I've used different colors for circles, colors for straights, etc. But utilizing this geometry, you can manually go and insert your road. If we were to, for instance, go to alignment, horizontal, edit alignment, you'll see our design file is blank at this stage. If I go back to alignment, horizontal, there's the different options available to you. You can graphically edit, insert, delete, move. I'm then going to graphically insert. And then I'm then going to specify which snap mode to use. Reading my prompt, it says indicate position to insert a new PI. So I go to the beginning of the road, I left click. You can go and give it a name like start, click on OK. Then moving on, just zooming in there, I'm going to this HPI, this point of intersection where the roads where the geometry lines intersect, and I left click. Moving on, go and put in my next PI. I'm happy with that position, left click. Right click and finish. Reverting back to this PI1, I can now go and edit it. I can go to graphical edit. I can go and click on PI1. And I can go and put in some additional information. Let's say we want a curve length of 300. Click on OK, applies that 300, right click finish. I can then go and place my cursor on either the beginning or end of curve, left click, and I can go and stretch it. So it's got a very user-friendly interface over here. If you find that it's correct, left click again. You can also go and take that PI and you can move it. So that was option number 1, to manually go and insert this information. Another option, just to show you over here, that information was recorded. So whatever you're doing graphically, it updates the spreadsheet. I'm going to go and delete those rows as an example. Another option, and I suggest that you use this option, I'm just only going to turn off my geometry lines. Another option is to convert this entire polyline into your road center line. That is probably the fastest way of doing this. Just to show you how you go about doing that, you go to alignment, regression, extract alignments, and you select the horizontal alignment, click on OK, and then you extract the horizontal alignment from CAD entities. This function I normally use for all my demos. As I mentioned before, it's very fast. You go and select the CAD entity and you extract it from the selected entity. If I were to go back to alignment, horizontal, edit alignment, you can see it's already gone and extracted all of that. You do have the option to go and update these values. Again, you could go and move them around, you could go and delete them, etc. Now, I'm going to step out of my comfort zone and not show you what I normally do in my demos. Because this is more of a user group, I'm going to use the function to select control points. So this is something that you can do as well. I'm then going to select another road file, and this will be road number 3. So this is how you go about creating another road. You go and select this icon. That will bring you to this dialog where you go and specify your generation method. You can go and give it a street name if you wanted to. Specify template. Now these templates that we have in front of us, This is what comes standard with the Civil Designer installation. It's not something extra you need to purchase. It's not an additional module. There's the path file, and I'm going to keep it simple and go and select single 6, click on open, and that is what the template looks like. You can see a cross-sectional preview. It picks up the template dimensions, goes and populates this information. If you want to, you can go and associate curbs. If I go and click on load group, going back to examples, selecting curbs, there we got the British Standard, we got the SABS, we got the Vanstone. So depending on what's important to you, you could, for instance, go and select barrier curbs, channels, combination curves, where you got barriers as well as channels, and you could go and apply it to that road. I'm then leave it as is for now. As mentioned before, you've got 128 different cross-sectional layers. Let's go and, for explanation purposes, call this ground cross-section, and this one we'll call design cross-section. And remember these layers, because as we go through the design process, we'll utilize these layers. Click on OK, click on OK. Here we've got Demo Street active. As mentioned before, we don't go to alignment, we don't go to regression, extract alignments. We don't extract the horizontal alignment. If you're doing road rehabilitation design, you are able to pick up the rest of these elements. So you could, for instance, pick up the vertical alignment, and we'll come back to this at a later stage, the super elevation and the road edges from CAD. And it's very easy to swap between the types of roads from dual to single. Focusing in just on horizontal alignment at this stage, we click on OK. And instead of using the one I normally use, I'm going to go and select control points. Now, I'm going to make my life a bit easier. I'm going to get Civil Designer to go and highlight these control points by selecting the line. There you can see the hook points associated with this polyline. Going alignment, regression, extract alignments, horizontal alignment, and then control points. Reading my prompt, I'm then going to select the appropriate snap mode. Reading my prompt, it says indicate start PI. So I put my cursor close to the start of the road or polyline. Indicate a point on the first straight. So as I move my cursor, you'll see that the cursor changes. There's also a little red square, so that indicates the jump point. And what that means is if I do left click now, it will jump to that point. Then reading the next prompt, indicate a point on the curve. And that's why I've gone and selected this polyline beforehand, because it's very easy to pinpoint the important click points. Indicate first point on the next straight. So I go there, left click, indicate next point on the next straight. So moving my cursor, boom, found it, left click. Indicate next point on curve. Indicate first point of next straight. Right, so you get the idea. Now remember that you're doing a 27 kilometer road design here. So this is going to take a bit of time to manually go and select the correct points. Just bear with me. If you do make a mistake, you do get an error message. Hopefully we don't get one of those. Coming to the end of the road, it says indicate next point for the next straight. I'm going to select the end point, and then reading my prompt again, indicate a point on the curve. We don't have any more curves, so I am going to press escape to stop. Going back to the design file, if we go to alignment, horizontal, edit alignment, you can see that it's gone and recorded all of this information. Again, you do have the option to go and change or customize these values. Before I finish this, I want to point something out. If we go back to your original center line that you drew in, you'll see that I've skipped, or I've made a mistake here. I forgot to go and insert that curve. Now with some software programs, you'd have to start from scratch. That's it. You don't have any second options. Within Civil Designer, you do have the option to go and edit this information. If I go to alignment, horizontal, and I, for instance, go and select graphical insert, you'll see we've got a PI 14 there, and I want to go and insert an additional PI. So more or less over here, I'm going to go and left click. I'm going to give it a more descriptive name, and Civil Designer will automatically pick up the PI number for us. You can straight away go and specify a curve radius. Click on OK. You can see what's happened. And again, what we could do, I'm going to right click and finish. What you could do is you could go and take one of these and you could go and stretch it to another point. You can also go and move the PI point. Once you're happy with that, you go to alignment, horizontal, coordinate, where it's very easy to go and customize your own chainage intervals. On a smaller road, you might have smaller intervals. On a longer road like this, you might want to increase the intervals. It could be that you've worked with the same contractor for many years. You've got your own style of doing things, so it's very easy to go and customize these intervals. Happy with that? Click on OK. Specify where you want your coordinates. Click on OK. And it goes through the coordination process. Still within the horizontal alignment functionality, so we haven't moved from this yet. We now go to cross sections and we extract. We extract cross sections along the horizontal alignment, 20 meters to the left and 20 meters to the right of the center line. We gather in information from surface number 1 and we don't store it, and I'm hoping this rings some bells and whistles. We don't go and store it to the ground cross-sectional layer that we created earlier. Click on OK. It goes through the extraction process, and this information that it's gathering, we're going to utilize in the vertical alignment. While this is busy, let's refer back to our workflow chart here. We've gone and created the roads. We've looked at the different design alternatives, the 3 alternatives. I used the less common option. And then we looked at the horizontal alignment. We used the regression functionality. Next up is our vertical alignment. Almost done. Looking at the chainage values at the bottom left hand side. Moving on to the vertical alignment, we go to alignment, vertical, edit alignment. This is currently what we have. We've got a start point and we've got an end point. What does that actually mean? The blue line is the ground line. The red line is our finished design level. Now you could go and right click here. You could go and select, for instance, insert PI, go close to a line, press G to jump to your ground and then enter, and go and give it a curve length. When you do this, it will go and update your grades. It will also go and update your K values. In a similar manner, you can go and right click. You could go and select move PI and you could go move it to any spot. We've got additional toolbars here. We've got ground line display settings to go and choose from. So you can either do that manually, and as you do that, you can see the spreadsheet would update, or you could ask Civil Designer to assist you with this. Taking you back to where we've already been, we've been to alignment, regression, extract alignment, and this time we're looking at the vertical alignment. And these values or criteria is fully customizable. Specify what you're looking for, click on OK. And if we were to go back to the vertical alignment, previously we just had one, let's say, call it curve. If I go back to the graphical view, you can see the amount of detail that Civil Designer has done for us. Zooming in just to give you an idea of what this all looks like. There's a good option. I can go and right click. I can again go and select Edit PI, click on a PI point, go and make changes to that. I could go and move this. I could go and customize what it is I'm looking for. Happy with that? Closing the vertical alignment and saving it. It says you have entered a new vertical alignment or edited an existing alignment without generating levels. Do you want to generate these levels? So Civil Designer is going to go and generate levels along the vertical alignment, clicking on yes. Just to recap, we've done the horizontal alignment, we've done the vertical alignment. Now we're moving on to templates. If you recall, when we created this road, Demo Street, we went and specified which template to use. And because of that, if you go to Tools and you go and select Template Paths, that template is already present. I'm then going to right click, select Template Editor, and I'm going to go and stretch it. Clicking on carriageway, it's very easy to swap between a dual or single carriageway. You can go and specify the initial width over here. You can go and specify your crossfalls or your grades. Looking at curbs, as mentioned before, we've got a whole library of curbs to go and choose from. We've got the Vanstone, we've got the British Standards, we've got the SABS. Looking at a curb, let's look at this one for instance. You can go and select Edit Curb, and there you could go and make changes to the dimensions of the curb. Civil Designer would also work out the quantities of your curb and your unit lengths. Looking at layers or pavement design, if I go and right click here, I have the option of TRH4 pavements, where you can go and specify things like your pavement type, climatic region, road, and traffic class. If you're not quite sure of the traffic class, you can go and select Calculate Class, put in the applicable information, and Civil Designer will give you the applicable traffic class. And from that, you have options to go and select from. If you prefer not to use the TRH4 pavement, you can go and select the Pavement Designer, where you can create a new pavement from scratch, or you can take an existing pavement and then add layers, edit layers, delete layers, and save it for later utilization. Data. You can either go and insert this information manually via the spreadsheet. Alternatively, you can go and use these components on the left-hand side of your template editor. So browsing through, the majority of these come standard. I've gone and added some of my own, but you do have the Sanrail V-drain as an example. Down the list, you got the trapezoidal drains. If you're happy with a particular drain, you can left click, hold it in, and then go and move it to where you want to place this V-drain. And it's very easy to go and delete this V-drain as well. Once you've gone and utilized one of these components, you can go to Template, select it, right click, edit, and you can go and edit these components. You can go and create your own. You can go and put in a whole library of components. We've got a component library under the Tools menu. This is a fairly basic template. I'm then going to go and load a more detailed template. I'm then go back to my usual demo files. In this example, you can see from this, you can have different cut and fill conditions. So depending on the amount of cut and fill, you would have different numbers of gabions until eventually you replace all the gabions with a retaining wall. And that retaining wall's height would differ depending on your different cut and fill conditions. Same thing applies to the right hand side. Depending on what you've got, it would then apply the appropriate components. Closing that, no need to save anything there. We're still using that original template. Click on OK. Let's go and update our workflow chart. We've already done the vertical alignment. We looked at the default, and then we used regression, and we just completed the template design. Looking at lane widening, so I'm going to go and move that off our screen. We returning back to the alignment menu. We've already done horizontal, we've already done vertical. Looking at edge levels, edit super. And this is really a recap of what our road currently looks like. Currently, we've got a crossfall of -2 on our left and right hand side. Everything's 4 on the left and 4 on the right. It's very easy to go and put in your own values here. Looking at the templates, this is the default template, the one that we're currently using. And then if we add curves, etc. If I go to the graphical view, on the top we've got the vertical alignment, below that we've got the width, and at the bottom we've got the super. Taking this opportunity to show you how you can go and put in lane widening. I'm then going to go and right click where my cursor is now, and I'm then going to select lane widening. I'm then click on a start point and then an end point. I'm then going to go and specify what additional width I want to apply. You can go and customize or round off these chainage values. Let's go and make that 20. End chainage, let's go and make that 20 as well. So we're applying it over 900 meters, and we've got a 100 meter transition. We want to apply it to the right hand side, click on OK, and there it is. It looks a bit strange, but if you zoom in, you'll see it actually looks very impressive. If I were to go back to spreadsheet, click on widths, you can see that's been updated. Now, as far as your super elevation is concerned, at the moment we've got, as mentioned before, the -2% on the left and the right. I want Civil Designer to assist with the super elevation. We go to alignment, edge levels, slave super. Looking at this dialog, we've got the horizontal curve number 1. It bends to the left. This is the radius of curve number 1. That is the curve length. You can go and specify your super elevation for the curve here. The beginning of the curve is at chainage 191.697. Civil Designer automatically works out your super development length. How does it do that? I'm going to press F1 on the keyboard, which leads directly to the hub file. Zoom down to the bottom and select design process. It uses this formula, the South African formula, to calculate your super elevation development length. I'm going to close that, and then I'm going to ask Civil Designer to calculate the rest of our road for us. Click on recalculate all, so that recalculates all the curves along the horizontal alignment. Happy with that? Click on close. It will then go and update these values with the new values. So there you can see, and it will tell you if you've got any warnings along the alignment. You can browse through it. You can go and make changes. If need be, you can go and right click here, you can go and insert rows, put in your own chainage values, type in your own grades over here, etc. In a similar manner, you could go and right click and delete these rows. If you go to the graphical view, you will see that the super elevation diagram has been updated. And this is what your road looks like from a long section. If I go and click on this icon here, you can go and specify what colors you want to use for your left and your right hand side, etc. Happy with that? Close it, save it. And now looking at our message, it says you have entered again a new edge control data or edited an existing edge control data without generating your levels. Do you want to generate them now? We click on yes, and what a Civil Designer does then is it goes and gives us elevations along the edges of our road. Remember, we've already got the vertical alignment elevation along the center line, and now we are generating these edge levels. Click on yes. When we go and generate them, we don't use the second cross-sectional layer that we created when we created the road. Updating our workflow chart, we've gone and put in the edge levels, and I showed you the lane widening. Moving on to the final three, applying the template, plotting, and quantities. Go to area volume, select apply template, and when we apply this template, we are applying it to our design cross section. This is where we had gone and put in the center line elevation as well as our edge level elevations. Click on OK. And this is actually a complete road design. Just to show you, if I go to section graphical edit and I click on a point, that is what our road design looks like. We picked up the vertical elevation, we picked up the edge levels, and then we applied the template to our edge levels. Because we have a finished road design, we can now go and plot it. Remember, we got 27 kilometers of road here we need to go and plot, which is very easily done inside Civil Designer. We go to plot, generate. We go and select which of Civil Designer's customizable sheet files we want to use. We then create layouts and dynamically update plots if or when the data changes. So what that means is, even though you've gone and plotted it, if you do go and make changes to your design, that plot will dynamically update. Click on next. If you want to plot all of your plots, then you would say auto scroll to the next page. You can go and specify horizontal, vertical scale. Because of Civil Designer's full-on integration, you're able to go and plot additional services. If you do have stormwater, sewer, water, and auxiliary services like gas lines, fiber lines, telecommunication lines, etc., then you can incorporate them into this plot. Click on next. Specify your planned plotting setup. So I've specified a scale of 1 to 1000 there. Sheet size. If you do want grids, those are your coordinated grids. You can include that. Instead of doing things manually by clicking on add, I'm going to say auto define along the alignment. And what Civil Designer does then is it picks up the center line of your road and plots along that center line. If you do want an overlap distance, you can go and specify that. Just asking for confirmation that you want the entire stretch of the road, you could go and customize that and put in your own chainage values. Click on the green tick. There we've got 27 plots. You could also ask for a key plan, and what that would do is give you a plan view of the different plots that you can go and customize. Click on next. If you do want setting out details here, I've opted for road PI list or curve list. It will include that in the plots. It probably does a plot per second. So this would take close to 27 seconds. Creating the layouts at the bottom, you can see it automatically names the different layouts for us. Right, there it is, just to show you a proper example, and then go and select the previous one. There's the setting out details. Zoom in to see what it looks like. And you don't have to define viewports for this. You can very easily go and select it and go and move it to another spot. You also don't have to mask the information behind that. In plan view, you've got your road information. Here you've got your long section. You can really go and customize how you want this. You could take your company's title block and incorporate this into the sheet files. As far as your PI details are concerned in the plan view, again, you can go and customize that. You can go back to your display settings. You can go to your horizontal curves. You can go and right click and specify what you want displayed there. The last thing I wanted to show you was the quantities. If you go to area volume, we give you numerous options to choose from. There you got your mass or cumulative layer work volumes, curb quantities, component quantities, component layer work quantities, your road signs, which we haven't touched on yet, your road markings, as well as report quantities. And with report quantities, this incorporates your entire project. If you've got 50 roads in the project, it would have all 50 roads here. They are subdivided into different categories. You can go and right click here and select recalculate. It would then go and calculate, in this case, the areas. At the bottom here, you've got the option of default combine. That would be all the roads that are already calculated. Or you can go and select custom report, where you can go and customize the report type. Reverting back to our workflow chart, we've applied the template, we've done the plotting, and we've looked at the quantities. Thank you very much for your time. If you've got any additional questions, please do let us know. Until next time, goodbye for now.